It seems broadcast has started. Let
Mm,
me just check if I can send it to people. Doo doo
mm.
doo doo. Give it a quick second. Chat will go here. Whoa. Perfect. Perfect. That's not what I want, but sure. Good enough. Good enough.
Oh, by the way, to study this, do we need to read the chapters to be
Um,
safe?
you don't need to, but it does help to read them.
Mm. Chapter 7 and chapter 6, chapter 13. Oh,
Okay, now let me just make sure that everyone else can see it. I'll send the link.
mm.
Okay. Save to playlist. Study sessions. Close. Share. Copy link. And then from here, I will send it to the Discord. Oops. 104. Paste. We're starting again. No trees this time.
Oh, tree. What?
You already know how to do the tree at this point, right?
Oh, actually, yeah. I
Okay.
saw you say a new character on your stream. You have a different anime character every single time.
Yeah, of course it's different.
Mm,
Why wouldn't it be?
mm.
All right, let's start this question. Note, we are going to be doing some questions that cannot be done without a solver. Therefore, what I will do is cut it off at that point. Can you hear me correctly?
Yes, I can hear you. Are we gonna use a solver now?
No, we're
But
not
I
using
thought
the
in the
solver.
final.
We're not using the solver. I'm saying is that some of the questions cannot be done without a solver. Therefore, if we get to a
Okay.
point where the solver is necessary, we'll just call it off.
Mm,
Does that make sense?
yeah.
Awesome. Okay. Project. Net present value dollar millions. What? Oh, space. And this is expenditure required in dollar millions. So do you remember this question?
Mm. Wait, I can't see anything.
Oh, you can't see my screen? Uh,
Yeah,
let me send it to you. Share. Can you see my screen now?
yeah, yeah, yeah. Now I see. Oh, this is Chibi no, from No Game No Life Zero.
Of course, this movie's great.
Yeah.
I read the book too.
Oh yeah.
Yeah,
Read a book too.
yeah, the
I
book.
only watched the movie.
The book is better.
That was really sad.
The movie is sad too. One,
Mm.
two, three, four, five, six. And the one will be 18. She's gonna lower it by one. And just assume that all of these have the dollar sign. I'm just not gonna write it down for the sake of not wanting to.
Yeah.
12, and this will be 94, 38, 85, 74, 118, 54. Please note everyone has different numbers. So if your numbers don't line up with mine, I don't know what to tell you.
Mm.
There are conditions that limit the investment alternatives. Hold on, let me put the timer. I almost forgot to put it.
Mm.
That way I don't go overboard, you know? It'll be 6 hours. Start. Okay, timer is now live. Let us continue. Conditions that limit the investment alternatives. And said conditions are at least two of projects 1, 3, 5, and 6 must be undertaken. 2. If either project 3 or 5 is undertaken, they must both be undertaken. 3. Project 4 cannot be undertaken unless both projects 1 and 3 are also undertaken. Are undertaken. Okay, and then our budget for this investment period is 220 million. So that's just the setup. Do you have everything followed
嗯
down so far?
嗯
Good?
more or less the budget. Okay.
Okay, A. We need to formulate the binary integer program that will enable BDC to find the projects to invest in to maximize net present value while satisfying all project restrictions and not exceeding the budget. Therefore, what I'm going to do is say let xi equal to open bracket 1 if project I is undertaken, semicolon 0 otherwise. For I is equal to 1, 1 comma 2 comma 3 comma 4 comma 5 comma 6, and then I have to give the function, give the objective function in millions of dollars. So does that make sense so far?
For
Yes?
me, I just don't remember this question now. I might need to see how it's done to see how to solve it.
Okay, so first let me ask you a question. Are we maximizing or minimizing?
We are maximizing
Why?
because you're trying to see not exceeding the budget. So we want to get as big as possible.
Correct. So looking at these numbers, what do you think we need to maximize?
The money,
Okay, let me narrow it down. Do we need to maximize the net present value or the expenditure
net,
required?
or net present value.
Good. Good, good, good. So let's do that. That should be pretty easy. Let's use a different color. I like orange today. So
Mm,
max for 18x1 plus 8x2 plus
mm,
16x3 plus 17x4 plus 23x5 plus 12x6. Looking at the
mm.
problem, do you understand how I got those numbers?
Oh, I see. 18S1, AS2. Okay.
Good?
Yeah, I see.
Yeah, these
Mm.
numbers here.
Right.
So now we need to write the constraints. So let me ask you this one. What are we constraining?
We are constraining the six, no, the result of six variables. not to exceed the budget.
So, what does that mean?
It's a net present value.
Mm-hmm. That's one of the constraints. That's the budget constraint, remember?
Budget constraint. Okay.
Budget
Mm,
constraint
subject to.
will be this part down here. But what are we constraining
Mm,
it by?
mm, by the budget.
Hmm, that budget is equal to?
220 million.
Correct. Now, for
Mm,
the sake of saving everyone their sanity, I'm just going to write 220. So
mm,
the budget constraint will be as follows: 94 x1 plus 38
um,
x2 plus 85 x3 plus 74 x4 plus 118 x5 plus 54 x6 is it less
mm.
than or greater than?
So this is greater than
Why?
because this is a budget is supposed to be the bigger one.
It's actually less than or equal to,
Oh, that's not equal to.
because we can't go above the budget.
Oh, okay.
Hmm.
Budget constraint. Oh, this is constraint. Okay.
But we still have four other constraints. What do you think they are?
Mm,
Let me open the question up again.
mm. The expenditure required. Mm, I don't really know.
Okay, so let's put it this way. We have
Mm.
up here, you see these three stars here?
Oh, yeah.
Okay, so let's look at these three stars.
Mm.
First, at least two of projects 1, 3, 5, and 6 must be undertaken, okay?
Okay.
So for the sake of separating those, we're going to use green. So
Mm.
constraint on project 1,
Mm.
3, 5, and 6. And that would
Mm.
be what? Do you know what it is?
And this. And these two of them. Mm.
You got this.
Mm. Equal to 2.
Why equal?
Mm. X1 plus X3 plus X5 plus X6 equal to 2.
Not equal.
Mm.
It's not equal. What is it?
Mm.
You got this. We're almost there.
Mm.
No?
Mm. Doesn't equal to 0.
No. It's not an equal sign. Let me put it this way. Your number 2 is
Oh.
correct, but what is the sign?
So less or equal to?
Um, less than or equal to, you say? That is
Mm.
correct. It is less than or equal to.
Okay. Oh dear, dear.
So let's look at it. So
Mm.
you would write it out like follows. Okay? It would be
Mm.
x1 plus x3 plus
Mm.
x5 plus x6 is greater than or equal to, my apologies, greater than or equal to 2.
Greater to or equal to? Okay.
And the reason for the greater than is
Mm.
because at least 2 have to be done. So in reality, if it was
Mm.
less than, it would be no more than 2. But that's wrong.
Mm.
Okay?
Okay. It's greater than or equal to.
Now let's look at the second bullet point.
Mm.
3 or 5 is
Mm.
undertaken. They must both be undertaken. How do you write that one
Mm.
down? constraint on 3 and 5. Let's use purple for this one.
Both undertaken.
How'd you write that?
Is x3 plus x5 or less or equal to 1?
No?
Mm.
Let's go
Then
back
is
to read the question.
x3 equal to x5.
Why?
So the x3 minus x5 equal to 0.
Look. Yeah, x3 minus x5 is equal to 0.
Mm.
But why? Because this is also correct what I'm about to write.
But they're equal to each other.
Yep. That is correct. Good job. So now we have to look at the third one. Project 4 cannot be undertaken unless both projects 1 and 3 are undertaken. How would you write that down?
Okay, so it's x1 greater or equal to x4. And x1 equal to 1. x4 greater or equal to 1.
Where did x4 greater or equal to 1 is come from? You got the first one right. What's the second one? It's 2 constraints. For project 4.
Oh, don't know. X4. We say x1 plus x3 minus x4 is less or equal to 1. And when we calculate, we see x1 and x3, they're both equal to 1. So it becomes 2 minus x4 less or equal to 1. We subtract both sides by 2, and negative x4 less or equal to negative 1. And when we divide them by negative 1, it becomes x4 is greater or equal to 1.
I think it's a bit simpler than that. It's x3 greater than or less than x4. That's all it is. And pretty much you can't go any farther than this without a solver. So for now, we're just gonna say that question 5 is finished, okay?
Okay.
So let's look at the next question. Effectively, what we're doing is making sure that we can at least formulate everything because, well, the truth is we don't have a solver on the exam. However, I know for a fact that simply just knowing how to do things will be easier when we get to vocabulary. Each product requires manufacturing operations in 3 departments: A, B, and C. The labor hour requirements by department are as follows. Isn't this so much easier than drawing a tree?
Yeah.
2, product 3, A, 1.5, 3.0, 2.0, B, 2.0, 1.0, and then 2.5, 3, that would be 0.25, 0.25, and 0.25. Okay. And then we
Wait,
have
what chapter is this one for?
chapter 7, I believe.
Hmm. Linear
Part
programming.
during the next production period, the labor hours available are 450 in Department A, 350 in Department B, and 50 in Department C. The profit contributions per unit are $24 for product 1, $27
Hmm.
for product 2, and $28 for product 3. Good? So A, formulate the linear programming model for maximizing total profit contribution. Let PI equal to units of product I produced for I equal to what? Equal to 1 comma 2 comma 3. All right. So now that we're here,
Hmm.
okay, the question just tells you it, so I'm just going to tell you we're maximizing.
Hmm.
But now I'm going to ask you the following question. What are we maximizing?
We are maximizing the products of A, B, and C.
The what?
We are maximizing the products of A, B, and C.
And what numbers would those be?
So 1.5 x1 plus 3x2 plus 2x3.
Very close, but that's for the constraints. What we're really maximizing is
Constraint.
profit, because what do businesses like having a lot of?
Oh, profit.
Exactly. So we have
Okay.
24, 27, and 28 for
Mm.
our profits in product. This is for product 3,
Mm.
product 2, and product 1. We're
Mm.
just going to say, for the sake of saving everyone time, uh,
Mm.
PI is equal to product. Product.
Mm.
And then I is equal to 1 comma 2 comma 3. And with
Mm.
that, we can start maximizing. It'll be 24 P1
Ugh.
plus 27 P2
Mm.
plus 28 P3.
Mm.
Good? But we're not done yet. We need to make the constraints. Where do our constraints come from, do you think? If anyone is watching in the chat, you're also able to just answer it as well. No? No idea? Okay, I'll answer it. You're you're subjecting the maximum formula to the departments.
Mhm.
So in this case, it would be subject
the
two
department.
would be
So
1.5 P1 plus 3 P2 plus screen, thank you, plus 2 P3 Is it? Now let me ask you the question. Where does the next number come from?
Mm.
What do you think? What number are we trying to do and what sign will it be? Hanson, you still awake?
Mm.
No?
Mm.
So in this instance, Hanson, are you okay?
I don't understand this. So when do we use 24p, 27, 28?
So
And when
that
do
was for
we
the
use
that's for the
1.5 for 3
maximize.
and 2?
This is for the
Maximize.
constraints. Yeah.
Okay, maximize and constraints. Mm.
Good. And so from here,
Mm.
we remember the linear hours available are 450 for department A. Given that we're doing the
Mhm.
constraint of department A,
Mhm.
what are we trying to do here?
We plug in 450 to P1,
What?
350 to P2, and 50 to P3.
Um, very close. But in reality, given that it's a
Mm.
constraint, you have this sign here, and it'll be 450 because
450,
this is
huh?
for department one.
Oh.
Okay, department one. So now we have to do department two. What do you think the constraint will be for department two? Gosh darn it. Ah, why does it do that? Why does this keep opening? I don't even know what's opening here.
Mm. And video editor, maybe that's what helps you stream this video.
No, I'm not even using this. It just stays open.
Hmm.
Okay.
Or do you want to delete it?
Yeah, even when I don't need it, it just does it sometimes. Okay. So anyways, let's get back
Mm.
to the idea here.
Mm.
What exactly do you think I need to do to get the second department's
Mm.
constraint? Actually, what part of this
Mm.
question do you not understand, if any? Just so I can know.
Ah, maybe all of it.
Okay, so talk me through it. Let's start from the beginning of the question. What do you need help with?
1.5, 3, 3.2.0. So there's 9 numbers here.
Yeah.
So how do I utilize
So these numbers are the number of hours that it
oh
takes the department to make a product.
okay.
These are the hours available for each department.
Okay.
So given, say hypothetically, that our friend here has 1.5, 3.0, and 2.0 hours, and they can have a maximum of 450 in
Mm.
department 1, we make our constraint like this. But now, see how
Okay.
department 2 has a maximum of 350.
Mm.
And department 2, department B actually, can make all of these.
Mm.
How would you format this?
I don't understand Japanese here.
That's not, don't worry about this. This doesn't mean anything. I just wrote this down for a good laugh.
Uh,
This is really the constraint here.
yes.
So now that we
Mm.
have this for department A,
Mm.
let's look for department B.
Mm.
So these numbers come from this section of the table, 2, 1, and 2.5. Correct?
Mhm. Mhm.
And seeing how they're all
Okay.
from the same product, we would get the following: 2p1 plus 1. Actually, we don't even need to write the one, just p2 because it's a 1 plus 2.5p3
Mm.
is less than or equal to
Mm.
what number?
2p1, p2, and p3. Yeah. No 350
Why?
because it's department 2, department B.
Yep. Good. So, if you understand that far, what's the third constraint gonna be for department C?
It's gonna be 0.25 p1 plus 0.25 p2 plus 0.25 p3, and less or equal to 50.
Correct. Good job.
Mm. Mm.
Good job. Whoa.
Mm.
Mouse, don't fail me now. P1 plus 0.25 P2 plus 0.25 P3 is less than or equal to 50. Good job. And then what's the final constraint we're missing?
Mm.
Do you know the answer?
No.
No? The non-negativity constraint.
Oh.
So how would I do the non-negativity constraint?
Mm. Mm.
Do you know?
Yeah.
So for the non-negativity constraint, we just gotta do P1, comma P2,
Mm.
comma
Mm.
P3 is greater than or equal to 0. That way nothing can be negative.
Oh, okay.
You sound very
Oh,
tired,
this
Henson. You good?
non-negativity. Yeah.
Yeah.
Oh.
So we're going to be skipping B and C because it's not doable without a solver. But D
Oh.
is.
Okay.
D.
Mm.
Management realized that
Mm.
the optimal product mix, taking setup costs into account, might be different from the one recommended in part B.
Mm.
So just so
Mm.
you know, for part B, in part B, um, the the optimal
Mm.
product mix was P1 equal to 60,
Mm.
P2 equals to
Mm.
80, and P3 equals to 60 with profit of $5,280. Good?
Mm.
So that's
Oh,
just given
that's
in the problem. We're
mm.
not solving for that. Formulate a mixed integer linear program that takes setup costs into account. Management also stated that we should not consider making more than 155 units of product 1, 190 units of product 2, or 200 units of product 3. And we're going to let PI equal to units of product I
Mm.
produced, and Y1 be the 0-1 variable, which just means binary variable, that is 1 if any quantity of product
mm,
I is produced and 0 otherwise.
mm,
For I is equal to 1 comma 2 comma 3.
mm,
So,
mm,
does this make sense to you yet?
mm. So equal to, okay. So I equal to 1, 2, and 3. I need to read the question a little more.
Okay, I'll just keep writing more. I just wanted to stop on the first paragraph, so give you a chance.
Mm. What is the option? Optimum product mixes P1 equal to 60, 80, 60. Profit. Okay, the small constraints.
A. What other constraints should be added? Linear program. Okay, so I finally finished writing the whole problem for D.
Mm. Okay.
Okay, so
Alright.
what you're gonna know is that everything here is still
Mm.
true except for our max equation. We have to change it. And
Mm.
our constraints are a bit different.
Mm. Mm.
These constraints still stay the same, but we need to add 3 more. Therefore, I'm going to be cutting some for the sake of space. So, our max... What was that? Our max is still the same. But we need to add something. It'd be 24p1 plus 27p2 plus 28p3. And then what are we missing from here? What else do I need to add based on what's in the question? Oh, right.
The subject to.
Hold on. I forgot. Set up costs
Mm. Mm.
are 410 for product 1, 500 for product 2, and 600 for product 3. Okay, now I finished writing it. I forgot to write the last part.
Mm.
So we need the rest of the maximum optimal equation, optimal function,
Mm.
objective function. So given that we have these new numbers, what does a cost do? Is a cost an addition or a subtraction?
It's. Mm. Mm. Subtraction from x4.
Yeah, we're subtracting. Good. But by how much are we subtracting? And what variable is it?
Mm. 410.
410. Okay, that's the
410.
okay. Minus 410.
Mm.
410 what?
Ah.
It's still in the same section. 410 what?
Mm. Oh, P
Not P. There's a number. There's a letter here that we keep using.
Y1.
Yep.
Mm,
And then we have
mm,
two more.
mm.
What else are we subtracting by?
Also 500 Y2.
Correct.
Mhm.
And one more.
And 600 Y3.
Correct.
Mm.
So that is our new maximum objective function. But now
Mm.
we have to write the constraints.
Mm.
What are the constraints? In addition to the ones we already got earlier. So the constraints from part A, we're not doing those anymore.
Mm.
Hmm.
Will be 60 P1. Wait, hold on. No. What the what? Mm. I don't know.
Okay. So the constraints we're looking for, thank you, would be units
Mm.
of product 1
Mm.
produced, units of product 2, and units of product 3. Good? And now, for the sake of giving you the answer, because I don't want to spend too long here, I'll explain it afterwards. It would be product 1 minus, and I gave you a number here. What numbers did I give here?
Mm.
Read this sentence. Management also stated.
Mm.
Okay. Management also stated that we should not consider making more than 155 units of product 1, 90 of product 2, 190 of product 2, and 200s of product 3. So P1
Mm.
is our product. Now we're going to get rid of
Mm.
units. So it'd be 155 Y1, and it has to be less than or equal to 0.
Mm. That's equal to 0
Yes.
for Y.
So the reason that it's less than or equal to 0 is because we can't go above this number.
Oh, go above this number.
We can't go above this many units for product 1. In a
And the
sense,
here,
no matter what we do, no matter how many units we produce, we can't produce more units than the cost of 155 Y1.
mm, wait, this is a cost?
Well, no, these aren't costs. This is the number of units. My bad.
Mm,
So no matter how
okay.
many units of product 1 we have, we can't go above 155 units.
Mm, 155 units.
So, say for units of product 2,
Mm,
how would you formulate it?
let's say P2 minus 190 Y2 that's equal to 0.
Like that. Perfect. So then what would be Y3? I mean product 3.
That will be P3 minus 200 Y3. less or equal to 0.
Correct. Now, we
Hmm.
already had the original non-negativity constraints,
Hmm.
which were just p1, comma p2, comma p3 is less than or equal is greater than or equal to 0. But what about y1, comma y2, comma y3? What are those?
Hmm. Hmm.
The
So,
key is here.
hmm. So the P1, P2, P3 less or equal to 0.
No, not yet.
Hmm.
Okay,
Oh.
so here, because the y's are binary units,
Hmm.
binary units always equal to what?
Hmm. Unit is always equal to 1,
Well, binary has two.
2.
So
Okay.
0, comma 1.
0 comma 1. Wait, 1, it means 1?
Yeah, 1 and 0. Yeah, 0, comma 1.
Hmm.
Okay.
Okay. Y1, Y2, or Y.
Because it's binary.
Oh,
Binary is a bunch of
hmm.
zeros and 1.
Okay, but Y0 and 1.
Well, you know what binary code is?
No.
Okay. So in binary, everything is calculated with 0 and 1. There's just a bunch of
0 and
it's just a bunch of numbers here. But here
1.
it'll be a yes or no statement. 0 being
Mm,
not at all and 1 being yes.
mm,
And that's how you get those numbers. And we can't really go farther than this without a solver. Therefore, the next thing we're going to do is go to the next question. Do you have any
mm.
more questions?
How many more?
Hmm? Um, not many more? Okay. Then let's go to question 3 then. I really hope that made sense. I really do.
Mm,
Because even I admit some of these questions are just really complicated.
mm.
You know what I mean?
Yeah.
Yeah. Paste. Yeah, I'm not making the same mistake I made last time. I have drinks with me this time.
Mm-hmm.
Because I'm not gonna lie, my throat was killing me last night.
Oh. Mm,
But we're good now. Alright, wait, what? Come on. Come on, come on, come on. You can do this. Faster. We're almost there. Do you see how long these
mm,
questions are?
mm,
Okay. We're not done yet. That's the funniest thing. Okay. Let, and then I gotta write the next part. So, x4 is equal to the number of 4-cylinder connecting rods produced next week. X6, my bad, is equal to the number of 6-cylinder connecting rods produced next week. S4
mm,
is equal to 1 if
mm,
production line is set up to produce 4 dash cylinder
mm, mm,
connecting rods, 0 otherwise. And
mm,
then S6, my bad, is equal to 1 if production line is set up to produce 6-cylinder connecting rods, 0 otherwise. Okay, so now that we're here, I gotta ask you, what is going on in this question?
X4.
Do you know?
Make a decision. We're trying to see if the production is passing the capacity, the weekly production capacity. So if it surpasses, then it's worth it. Then the S4 or F6 will be accepted. If not, we just reject it.
Hmm.
I don't.
Remember, I just need
I
to make
don't
sure you
know
understand
anything.
what the setup is first.
Hmm. Hmm. Hmm.
Okay, so I'll explain the question after, but for now, I
Hmm.
gotta finish writing this up. If you can
Hmm.
tell me what's going on in the question, please let me know.
Okay. Hmm.
Any constraint?
Hmm.
You're tired, huh?
Yeah, I don't even know what's going on with this question.
You don't know what's going on
Just
in this class?
hmm. So what chapter is this?
This is chapter 7.
Chapter 7, yeah, linear programming.
Yeah.
Hmm.
Okay, so the decision variables x6 and s6 write a constraint that limits next week's production of the 6-cylinder connecting rods to
Hmm.
either 0 or 6,000 units. And then D will be write a third constraint that, taken with the constraints from parts B and C, limits the production of connecting rods for next week. Okay, so these is everything we need to write.
Hmm.
Okay. Let's see.
Hmm.
Limit the production. So first, how do you think we write the objective function? Looking only what's here.
To minimize the number of substations,
Correct, we are minimizing.
we, we use s equal to 1 or 0.
Give me a quick second. So you know, we are minimizing.
Hmm.
So let's open this again. What exactly
Hmm.
are we minimizing?
The number of stations.
where do you get those numbers from?
From the questions.
Okay,
A plus xb plus xc plus xd plus xe.
where's SDSE? Where are you getting those numbers from?
So xa, xb.
There is no XA in this question.
Oh no. Wow. Hmm. I don't really know which one.
Okay, so what we're minimizing, just so you know,
Mm,
is the cost of production.
mm, mm. Terms of production. Okay.
You good?
Yeah, just about
So,
production.
given that we're minimizing the cost of production,
Mm,
what are we producing here? So we look for the costs, okay? 13, 22,
mm,
32, and 16. Good? So X is the number of cylinders, and 13 is the cost of a cylinder. So it would be 13x4, and the 4 comes from the fact that the question states 4-cylinder. So 16 for a 6-cylinder will be plus 16 x6 plus, and now we got to look at the production line to produce it is 22 and 32, and this is the cost for producing, and we know the production line is in the s's. See,
mm,
so it'll be 2200 s4 plus
mm.
3200 s6. Does that make sense?
13x4 plus 16x6 plus 20.
2200 s4, 3200 s6.
Mm. I don't really know why we do it like this.
Like what?
Using 13 and 16
Well, that's because that's the cost, okay?
cost.
And you pay
Okay.
cost per unit. X4 is in
Mm.
units. So
Okay.
13 times whatever many units is the cost. And we want to minimize our
Okay.
cost.
Okay.
Good?
Yeah. And 2,200.
So that is the cost of having the production line running.
Also having the production line running. Okay.
Good?
Yeah.
Okay. So now let's look at part B. Using
Mm.
the decision variables for x4 and xs, write a constraint that limits next week's production of the cylinder connecting rods to either 0 or 9,000 per unit.
Mm.
How would you do that?
Mm.
Not per unit, just units.
Mm. Mm.
So, you know that units are in the x's, right? So, we start with x4. But now we have a question. What sign do we put here? Because the answer already gives you the other number. It's 9,000
Mm.
S4.
Mm.
But what sign do we put here?
Mm.
Is it greater than, less than, equal to, greater than or equal to, or less than or equal to?
Mm.
Let's go back and look at the question. It's a limits. What does the limit usually mean? Well, given that we're limiting, it's going to be no more than. Therefore, x4 is less than or equal to 9,000 s4.
Mm.
Does that make sense, Hansen?
9,000 S4. So
Mm-hmm.
9,000, let me see, yeah, it's units.
Yep, it is units. Good?
Mm. Yeah.
Yep. Okay. If that's the case, then what's the second constraint looking at C?
Mm.
Do you know?
To see is we use x6 less or equal to 6,000 s6.
6 less than or equal to 6,000 S6. You are correct. Good.
Mm.
But now, we're missing something.
Mm.
Do you know what we're missing?
Mm.
Well, what we're missing is the next constraint for part D.
Mm.
Write a third constraint that is taken within consideration from parts B and C, limits the production of connecting rods for next week. How would you write that?
B and C, let's see. X4 plus X6. Well, I don't really know.
Okay, so in this instance, you gotta realize that they're doing
Mm.
a. Give me a second.
Mm.
Okay, sorry, I had to sneeze. So what they're doing here
Mm.
is a question that they're saying it has to equal 1.
Mm.
So the way you would write this out is S4 plus S6 is equal to 1. Because this limits the production of connecting rods. It cannot go above or below, it's only that.
Mm. S4 plus S equal to 1. Okay.
Do you know why that's the case?
Mm. No.
Because this constraint is one that, taken with the constraints from
1,
parts B and C, it
B,
limits production of
C.
connecting rods for next week. So in other words, we can't go above it. That's why it's 1.
Mm. Okay.
There is more.
Can't go above it.
Yeah,
Mm.
there is more, but the problem is that we can't do a solver on the exam. So this is probably where the question
Mm.
would end.
Okay.
And
Mm.
now we get to do graphs. Are you feeling happy now?
Mm.
Don't worry.
We can do graph.
Don't worry.
Mm.
It's not a tree, so you'll be fine.
Mm.
So consider the following all integer linear program. Should be max x1 plus x2 subject 2. So in other words, now we get one where it's already done for you. 5x1 plus 7x2 is less than or equal to 47. The next one is x1 plus 5x2 is less than or equal to 20. And then finally, we have 2x1 plus 1x2 is less than or equal to 17. And then finally, x1 comma x2 are greater than or equal to 0
Mm.
and are integer. Meaning they can't be, they can't be point something, because that would be ridiculous.
Mm.
So step 1, A, we have to graph the constraints for this problem. and use dots to indicate all feasible integer solutions. Good? Let me ask you a question, Hansen. Do you remember how to graph?
It depends on what kind of graph.
What? I'm not sure what you mean by that, but here we go. Okay? So for the sake of simplicity, I'm gonna make all the constraints different colors. So 5x1 plus 7x2
That's
less than or
2.
equal to 47. Next constraint will be green, and that will be x1 plus 5x2 is less than or equal to 20. And the next constraint will be a nice yellow, which will be 2x1 plus 1x2 less than or equal to 17. Good? Now, thankfully, because of the matter that none of these can be 0 and they're all integers, we don't have to go very far in terms of numerical values. Matter of fact, we're only playing with quadrant 1. This will be x1 and this will be x2. Good? Now, for the sake of my sanity and yours, I'm going to make the font size 3 so that I can do this. 1, 2, 3, 4, 5, 6, 7, 8. I think I should go a bit higher than 8 though. I think I'll go 9 and 10. Whoa. The screen is freezing on me and I don't know why. That'll be x2. So for this number here, I'll also do 1, 2, 3, 4, 5, 6, 7, 8, 9. I think 9 is good enough, right? Yes? Okay, perfect. So now let's start doing some math. Some good math. So for 5x1 plus 7x2 less than or equal to 47, at x1 equals to 0, x2 will be equal to 47 divided by 7. And if we pull out a calculator, let me pull one out. I realized I put it in my backpack last night. The number we get here is 6.5 over 7, something like that, right? Yes? Let me just look at
Oh, by the way, why is x1 equal to 0?
We're just setting it there.
Is that ex1?
No, that's just at.
At.
So this will be 6.714. Just for the sake of convenience, we'll just have it around here. And also, just to let everyone know where the numbers are located, they'll be around here. That way we all know where the numbers go. Because I just realized it would have been foolish of me to not mark these off. 9. Perfect. But now we have the second half to deal with. And that would be at x2 equals to 0, colon, x1 is equal to 47 divided by 5, which will be equal to 9.4. Is that correct?
9.4, yes.
Yes. So it'll go around here. So now, what we gotta do is connect dots. And I will not claim to be the neatest writer, but what I will claim is that I'm a compact writer.
Mm.
So what's next is to remove this section here, because I'm
Mm.
assuming you have this part memorized or
Mm.
written down. You know what? Let me ask you a question, Hanson.
Mm.
Are you writing down the stuff I write down?
Yes, I finished writing it.
Good. So now we gotta go to the 7, the green section. Isn't this nostalgic? We're doing graphs again. And you're probably wondering, how do you mean nostalgic? I don't know.
Mm.
At the beginning of the quarter, we were doing graphs, and now at the end of the quarter, we're doing graphs. Because this is just these are just the most recent homeworks. That's why I'm making them. So here we have these numbers. At x1 equals to 0, colon, x2 is equal to 20 over 5, which is equal to 4. And then x2 will go to 4 here. Good. And then x1 will be 20 something. So x2 equals to 20 equals to 0. x1 is equal to 20. So somewhere over here, it's a really big number. We're just gonna try to connect it haphazardly like so. Bam. And over here, there should be 20. And now we have the next section, the yellow parts, because this is the truth of it all. When we're graphing, you have to do everything. It takes a while, but at least these are easy graphs. Am I right?
Mm.
So now 2x1 plus 1x2 is less than or equal to 17. At x1 is equal to 0, colon, x2 is equal to 17. And then at x2 equals to 0, colon, x1 is equal to 17 divided 2, which is equal to 8.5. Is that correct?
Mm. 17. Oh, this one. Oh, okay. The 3. Okay.
Good?
Yeah.
Okay. In turn, what this will do
Yeah.
is influence my decision on the graph. Hold on.
17 and 8.2.
x2 will be... Oh, I made that backwards. Thank you for pointing that out.
8.5. Oh, yeah.
Yeah, you see where I messed up?
Yeah.
Yep.
17. Oh, damn.
Yep. So in reality, this number goes a lot higher. I didn't realize that all of this line was here. Yep, so in reality, the yellow part should be down here at 8.5. And up here, it should go like 17 or something. Whee! So now that we have that, we can finally connect all the dots. Good? And we'll go back to 5 for the sake of connecting the dots here. It'll be as follows. It'll be sort of like this. 1, 2, and then 3.
One, two, three.
Yep, these are our little connectors. These are our extrema. But now, we can only work with points that exist within the extrema. So therefore, the points that exist are 0, 0, and I'll actually use different colors for this. I use black. It'll be 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. And then we have 1, 0, 1, 1, 1, 2, 1, 3, 2, 3, 4, 5. Do you see what I'm doing?
Yeah.
Yep, good. All of this for the sake of getting this done, right? You good?
See this from the homework. problems. Okay.
Yep, this is from the homework.
Mm. Yeah, I didn't pay much attention. I just wanted to get it over with, so I just saw the solution there.
I know that feeling.
Mm.
2, and then 1, 2. Therefore, this is how you draw the graph.
Mm.
So that's part A done. Does that make sense to you?
Yes.
Good. Now, what I'm going to tell you next is that we can't actually do the rest of this without a solver.
Mm.
Well, I mean, we could, but we would have to plug in each and every individual point.
Plugging every one of them. That's like how many? Like
Um,
30.
like 30 or so, yeah.
Mm.
Now, if you want to know the truth, the answer to that would just be. Let me get a different color. Let's use
Mm.
white. The correct answer would be at x1 comma x2 equals to 8 comma 1,
Mm.
and then you would just plug that in. It'd be 40 plus 7 equal to 47. But that would just take plugging in way too many numbers, and that would take too long. Do you agree? Good. Hello. Okay. So now we're gonna do question 1, which
Mm.
honestly didn't make that much sense to me, but let's have at it. Before anything, did you understand this question? The question we just did, the graphing the thing question.
No, I think I understood that one. I just need to plug in every dot
Yeah.
inside the line.
Yep.
All 3 lines.
And that would take forever, right?
Mm. I need to master this so I know what's going on in the test. I hope my mind won't go blank. Just need to do the practice problems and the practice homework again and again and again.
Right. The LP relaxation. You know what? I'll give it this. Um, about 1 hour. So in 3 hours and 40 minutes, we can go over the
Mm.
practice problems again because we did that in the first one, but you weren't there for
Mm.
it. And also, doing the practice problems is probably the best because those are going to be the ones closest to what we're doing on the exam. I'm just doing all of the problems so that you have an idea of how to do
Mm.
this in case he throws
Oh,
any curveballs.
curveballs. Linear program. I just don't. Not used to it.
You're not used to it?
Mm. Since sometimes I don't even know the fundamentals correctly. Ah, just reading the notes again and again.
I'm gonna tell you the truth, right? Reading the slides, I don't know. To me, that never worked.
Mm.
You have to practice the
Do-
slides.
Yeah, do the real problems.
Not just doing problems, okay? You can practice definitions. You can make flashcards or something. I don't know. Just reading it
Yeah.
doesn't seem to do anything for me.
Mm.
Plus
That
2x.
reminds me about flashcards.
Yeah, very good. That's why I use Quizlet because I kept running out of paper throughout my life.
Mm. Yeah.
x1 plus x2 is less than or equal to 150. Okay, so seriously, this
Mm.
question makes no sense, and I don't know how I got it right.
Mm.
Because I
Ah.
don't even know what he was asking. I just plugged in everything again.
Mm.
So let's begin with this one. Is this linear program an all integer program or a mixed integer program? Let's answer that right now.
Mm.
What do you think it is?
Hmm.
Hmm. Come on, Hanson. You can do it. I'm gonna assume you just have no idea.
Uh-huh.
Okay, so
It's a
what is a linear
mixed
integer
integer.
program?
Yeah, mixed.
Yeah, it is a mixed integer program. Yeah. This
Mm,
is a mixed integer program. Why is this a
yeah,
mixed integer program?
because it's x1 and x2.
No. It's a mixed integer
Hmm.
program because we're using decimals.
Decimals.
Mm-hmm.
Ah.
Good?
Don't x1 and x2 are different variables?
Yeah, they are, but that's not the point. Variables, not
Hmm.
integers.
Uh, aren't they like
Integers.
x and y?
Okay, let me put it this way. Let's say we have
Mm.
2x, right?
Mm.
The variable is x. After all, a variable is a letter used to represent an unknown number. Good? And the 2 in this instance is the integer. This is what the variable will be multiplied by. 2 is linear, whereas 1 divided by 3, for example, is not. Does that make sense? Yes?
Oh, it's 1/3 is not. Oh, yeah, I see. Yeah, it makes sense.
Okay, perfect.
Mm.
So now that we have that, let's go to the next section. Write the
Mm.
LP relaxation for the problem.
Oh.
Okay? Now, LP relaxation, do you know what that means?
A linear program. Mm.
So, LP
That's
relaxation, this is to take the linear programming problem and remove integrality constraints from each variable. Do you know what that means?
remove integrality constraints from. So we try to make every one of the linear or integer
No, we're trying to
if
not
it's
care about it. We don't care if they're
not
integers.
care. Hmm. Integrality. I'm so confused. I don't know what's going on here.
Well, maybe if I write it for you, it will make more sense, okay?
Okay. Mixing integral. Hmm.
So, I kid you not,
Hmm. X1. Hmm.
that's it.
Hmm.
That's all we did.
Okay, S1 and S2, they are both larger or equal to greater or equal to 0.
Let me ask you this. What is the difference between this one and this one?
difference that one is 7, the other one is 3.5.
No, between this top one and this
Mm.
bottom one. What is the difference?
There's no indication that x1, x2 is larger or equal to 0,
Yes,
and they never say x2 is an integer.
there is still an indication that x1 and x2 are 0. The integer thing, in a sense, this
Mm.
is gone because this is the integrality
Mm.
constraint. An LP
Integrality
relaxation problem is
constraint.
just removing integrality.
Mm. Integrality constraints.
Yep.
What is a integrality constraint?
Saying that something has to be an integer. That's it.
Okay, something has to be integer. Okay.
We're just removing that constraint.
Mm. Okay.
So let's look at this one.
Mm.
Check 2, 1. It'll be 4x1 plus 6x2 center equal to 8. 2. You know what? Let's just put these back just for the sake of it, right? Okay, so putting these stuff back, let's go back, and we have 4x1 plus 8x2 is less than or equal to 12. Good?
Mm.
Then, of course, x1 comma x2 are greater than or equal to 0 and integer. So now let me ask you this. Is this, instead of typing it, let's just copy and paste.
Mm.
Shit, Control C, Control copy, Control paste. Answer this following question. Is this program an all integer program or a mixed integer program?
This one still mixed integer program.
Why?
Mm. Because ah,
Remember the integrality definition I gave you when I explained 2x.
okay. They so this one is an all integer.
It is, but why?
Mm. Because integrality constraints.
What? No. It's an integer because
Integrality.
all of these are linear numbers. These are
Mm.
not irrational numbers. These aren't fractions. None of that.
Mm.
These are all just linear numbers. Therefore, it's an all integer program. 1 is an integer, for example. Because realistically, you can say that this is a coefficient. But 1 is an integer because it's just a number. 7 is an integer because it's just a number. Good?
Mm. Mm.
Great.
Mm. Ah.
So now,
Mm.
let me put it this way. How would you write the LP relaxation of the problem?
Periodization. What is periodization?
No. LP relaxation problem.
Okay. LP relaxation.
So pretty much, how do you take a constraint like this one and turn it into something
Mm.
like this one, but only for
Ah.
this one instead?
Mm. Minimize. So we need to minimize it.
It's already minimized.
Yeah, that's how we. Mm. Yeah, I don't really know what's going on here.
Okay, so we gotta do
Mm.
for the to remove the to create an LP relaxation problem
Mm.
is just get rid of this section here.
Mm. So there's no integer.
That's all it is. That's all you gotta do. Keep everything else the
Just like
same.
that.
Yep, just keep everything else the same.
What? That's
Easy, right?
called relaxation, LP relaxation.
Yeah, relaxation.
Ah, LP relaxation. Oh my gosh.
What?
So copy the same thing and get rid of integer.
Yep, the integrality.
Mm.
Does that make sense now?
Mm.
Good?
Okay. Oh my god. Mm.
Is it good?
Yeah.
Alright, homework
Mm.
assignment 7 is done. All we have 6 is done. Now the only thing we have is
Mm.
homework assignment 5. Oh shoot.
Oh. Mhm.
Okay. Let's do this, right? Let us do this.
Mm.
So, what'd you think of the previous homework assignment? Because we went over the entire thing in less than 2 hours.
This one was much shorter than the one from yesterday.
Well, that's because we didn't spend half of it drawing trees.
Yeah. Mm.
Could you
I can't look at
imagine?
trees the same anyway.
What'd you say?
I can't look at trees the same anymore.
You can't look at them the same anymore. So, if I showed you a tree, would you just scream in abject horror?
No, that should be you because you're the one doing it.
What? It was fun.
Mm. Yeah, I need to have more confidence in myself. Yeah, it's most of the time when I draw a tree, I just mess up a step and then I just no confidence anymore. Say I'm gonna mess up anyway. I don't wanna draw it. It takes so much time. Oh, that's a more reason I should keep drawing it until I get it right.
Yes. Actually, let's get rid of this. Let's lower the font size again because we're doing something smaller. When we're just writing,
Mm.
it's gonna be 3. When we're actually drawing something big, we're gonna use bigger font. Okay?
Mm. What? Mm.
Chicago is 1,
Mm.
and then we have 2,
Mm.
3. Give me a second. I have to draw this. 4,
Mm.
7 over here.
Mm.
6 is over here,
Mm.
and up here is 5. Now, allow me to continue by putting a different color. We'll use orange here to connect all of the dots.
Mm.
Everything must be connected. Right?
Mm.
I want you to know that this is not drawn to scale. Okay? Give it a quick second. You know, I'm very glad what the hell, it doesn't flash for you. But for me,
Mm.
every number is flashing like crazy.
You mean greenish flash? Flashing in green?
No, it's just flashing in general. Like my screen will go black for a few seconds, level of flash.
Mm.
But it doesn't
That
pick it up
doesn't
on the
make sense
recording.
at all.
But for some reason, the recording doesn't pick it up.
Mm.
So it must be a problem with my monitor instead.
Mm.
25, 15, then over here will be 13. Over here is 17. Over here will be 25. I just realized that these two need to connect.
Mm.
And this will be 10. Then over here will be 10. And that's pretty much the big graph here, correct?
Mm.
So the question is asking us to find the shortest distance. So please read this out loud so everyone can hear.
Morgan Trucking Company operates a special pickup and delivery service between Chicago and 6 other cities located in a 4-state area. When Morgan receives a request for service, he dispatches a truck from Chicago to the city requesting service as soon as possible. With both fast service and minimum travel costs as objectives for Morgan, it is important that the dispatch truck take the shortest route from Chicago to the specified city. Assume that the following network not run to scale, with distances given in miles represent the highway network for this problem. Uh, just looking for the best one. Okay.
Okay.
Find the shortest route distance from Chicago to Lot 6.
Okay, so the goal, as stated in the question, is to somehow end up here. Lot 6, right?
Mm,
So
uh,
now, this is pretty much what we gotta do. We gotta brute force this one. How do we get to lot 6 in the shortest distance? Give me a bunch of paths. Start with 1.
或者是这里 let's see, we go 25 and then plus 14, and so from 1 to 4 and then to 3 and to 6.
Which in turn will be 25 plus 14 plus 25
Will
equals
be
64.
64. Yeah.
Okay. Now give me another path.
Another path, I can go 1 to 3 and to 6.
Okay. So that'll be 35 plus 25, which will give us 60.
60.
Okay? Give me another path.
Then I can go from 1 to 2 and to 5 and to 6.
Okay? So that'll be 40 plus 17 plus 10 will equal to 67. I need another path.
I can also go 1 to 2 and to 3 and 6.
Okay. If 136 is smaller, this path is automatically crossed out. We don't care about this path. Next path.
Yeah. We can go 1 to 4 and to 7 and to 6.
Okay. So that'll be 25 plus 20 plus 10 equal to 55. Is there any other path you would like to try?
No, this is the shortest one.
Correct. Shortest path found. Good. We did it.
Yeah.
What'd you think of this problem?
This one's easy.
Easy, right?
Yeah.
It looks messy though, I'm not gonna lie.
I should have found the shortest path in the beginning, but I forgot about this problem, so I just.
Yep.
Yeah.
Yeah. If you're gonna do it without a solver, you pretty much just have to brute force it. There's no real intellectual challenge with it. You just gotta nap at it until it goes away. But now let's do some hard stuff. I just started with that one because it's easy.
Yeah.
3 similar products. Okay, so we have product, and then we have orders in units. So this will be A, B, C, and then this will be 1900. Oops. This will be 400, and this will be 1400, correct?
Okay.
Good?
S1 plus B. Okay.
And then I'm gonna do some copy and paste shenanigans because I don't want to type this whole sentence out. It's too long. Was that your message or my message?
Don't know. Maybe it's my message.
Actually, you know what?
I don't see anyone.
I'm just gonna check mine because I heard it too. You heard it too, right?
Yeah, from Discord. Yeah.
Okay.
But there are some channels I muted, so they don't show I'm being added.
And the answer is it is not me. Good. Good, 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 good. Okay. Good.
Mm.
So now we gotta do the things again. Machine capacity
Mm.
in units.
Mm.
This will be 1, 2, 3. It'll be 1,500. Whoa. This next one will be 1,500. And then this next one will be 800. Good? And then the next one we have to do the product. So product. This will be in a given that statement. That way we can just write machine. This will be 1. So it'll be 1, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That works, right? Do you know what I'm doing? Hanson, you still awake?
Yeah,
Perfect.
1, 2, 3. That's like X1, XA1, X something like that. And
Yep.
A1, A2, A3.
Yep. Are these all the same size? They look like it. Okay. Be
Mm.
1. Assuming I'm just assume that I have the $sign there for the sake of saving space.
Mm.
Whoa.
Yeah. Yeah. Okay.
2.4. These are in dollars, by the way.
Yeah.
0. Then we will have 0.9,
Mm.
1.2, and 1.2.
Mm-hmm.
Now that we have these tables, we gotta develop
Mm. The linear programming formulation.
of this problem. And we will let x of a1 be the number of units of product A produced by machine 1 xij be the number of units produced, of product I produced by machine J, etc. It really just says etc. Okay. So first, let me ask you a question. Are we minimizing or maximizing?
We are minimizing
Why?
because we are trying to keep it under the budget.
Correct. But now let me ask you this question. How would we write this thing?
So we are using the chart we made earlier. There's
You made 3
product and
charts.
machine.
Which one are we
There's
making?
A1, A2, A3, B1, B2, B3, C1, C2, C3.
Perfect. So,
Yeah.
in other words, just to demonstrate it, because this is going to be a rather long one.
Yeah.
Whee! Let's write it out. XA1 plus 1.2 XB2 plus 0.9 XC. That's a terrible C. XC3 plus 1.3 XA2 plus 1.4 XB2 plus 1.2 XC2 plus 1.1 x a3 plus x b3 plus 1.2 x c3. And that's what we're minimizing. But now we gotta write our constraints. Okay?
Yeah.
What kind of constraints do we need for this project, for this problem?
Subject to machine 1 capacity.
What else?
Machine 1, then it has a product A, product B, and product C. And we have to keep it under 1500 capacity as units.
Perfect. Okay, so because that's a bit strange to say out loud, let's just show it off. It'll be xa1 plus xb1 plus xc1 less than or equal to 1500. Good. Now let's do the next constraint. What is the next constraint?
The next one is a machine 2 capacity.
Okay. And how would you
And
say
it
that?
has because machine 2, it has a product A, B, and C as well.
Okay. How would you write that? Just say it out loud.
It will be SA2 plus XB2 plus XC2.
B2 plus XC2. What's next?
And it will be lower, less or equal to 1400.
Oh, we have different numbers.
Different numbers.
Oh, you're looking at your homework. That's what's going on.
Yeah.
For these numbers, it's 1500, okay?
Okay, 1500.
Now, what's next?
It will be X, it will be about C. No, about machine 3. And it also has a product A, B, and C.
Okay, how would you write that?
It will be XA3 plus XB3 plus XC3.
And then let's look at the table. What number do we put in there?
And less than 800.
Correct. Good. So let's look at the next one now. What's the next constraint we need for this? Come on, Hanson. We got three more. Actually, we got four more constraints to write.
Okay, it has a product A orders.
And how would you write that down?
XA1 plus XA2 plus XA3.
Okay. Whoa, wait, cancel. What the hell? Yep. The orders, mouse, thank you. It'll be XA1. Why did I write it like that? It will be XA1 plus XA2 plus XA3 is what?
It will be 1900.
But what's the sign?
Is equal to.
Why is it equal to?
Is XA1 plus XA2 plus XA3 equal to 1900.
Yes. Okay. What is the next constraint?
There's one thing I don't understand. But why is it equal to this time?
Okay, so I believe that the reason it's equal to is because you always want to have as many orders as possible. So it doesn't even matter, just keeping it at equal to. Yep, I clicked insert. Okay. So, what's the next constraint?
It will be xb1 plus xb2 plus xb3.
Okay, but what is that constraint called?
It's a product B orders.
And yes, you were right. It is exactly how you said it would go. So it's
Mm,
x b
mm.
1 plus x b2 plus x b3 equal 2. And then looking at the tables here, what number would it be?
It will be 400,
Good.
equal to 400.
And finally,
Mm,
what is the second to last constraint?
mm. It will be product order C orders.
Yep.
Product C orders.
Okay. So please tell me, how do I write that down?
It will be xc1 plus xc2 plus xc3
Continuing.
and equal to 1400.
Good. And now, what's the final constraint?
It's final constraint x I j is large greater or equal to 0 for all I and j.
Good.
But I don't know why this is here.
It's to prevent everything from being negative.
Mm.
I and J represent A, B, C, and then 1, 2, 3.
AB3, ABC, and 1, 2, 3.
Yes. So, just for the sake of the audience at home, I and J represent A, B, C, 1, 2, or 3. Okay. Now, sadly, we can't go farther than this because we need a
We
solver.
need a solver.
So we're just gonna cut it off there. Was that cool? Wasn't that cool?
Yeah. Yeah, it's cool.
Okay.
Mm.
So now, you're gonna watch me draw not a tree, but a transportation problem. You're gonna watch me draw a network representation. Are you ready?
Yeah.
There's no enthusiasm, Hanson. Come on, you gotta be happy. It's the last exam.
Yeah, let's go. Yeah.
Yeah,
Last session.
let's end the year strong. Okay?
Yeah, finish strong. Army finish strong.
Yeah, exactly. There's no reason to have this sleepy attitude. No, 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 no. You gotta be happy. So we're gonna finish this, and we're gonna pass our classes, and then we move on.
Yeah.
Kansas City, and this will be St. Louis. Perfect. And these are all covered in circles. Bigger circles than I would have admitted to care about, but yes, circles nonetheless. And then back to the other colors for green. These will be 20. This will be 15. And this will be 50. So then from here, we're going to have to draw the lines. We're going to use yellow for our lines. Do you remember how to draw these?
Yeah, I just connect them 1, 2, 3, 2, and then 1, 2, 3, like that.
Yep.
And there's a certain number on all of them.
So I'm just gonna give you the numbers because the question gives you the numbers. But if he tells
mm,
you to put the numbers in, you gotta do it manually.
mm,
Okay. 9, 8. Then down here it's going to be 8,
mm,
11,
mm,
and 26.
mm.
Perfect. This is the following network representation of a transportation problem. Good?
Mm. Oh.
I tried to be as neat as I can, but I'm not perfect, Hanson,
Mm,
okay? Even I am subject to mistakes. Paste. Bowler. Okay. So now let's look at this.
mm.
Do you see it? Yes or no? Hello?
Mm.
Hello? Hanson, you still here?
Yeah, I'm here.
Okay. Please read this for the audience.
Mm. The supplies, demands, and transportation costs per unit are shown on the network. A. Develop a linear programming model for this problem. Be sure to define the variables in your model. Let X11 become amount shipped from Jefferson City to Desmond. X12 equal to amount shipped from Jefferson City to Kansas City. X13 equal to amount shipped from Jefferson City to St. Louis. And X21 equal to amount shipped from Omaha to Des Moines. X22 equal to amount shipped from Omaha to Kansas City. X23 equal to amount shipped from Omaha to St. Louis.
Good. So now I'm gonna do something a bit different. Instead of just hard writing everything on the thing, I want to keep this
Mm,
thing up. So first, tell me,
okay.
what are we doing in this question? Are we maximizing or minimizing?
Well, minimizing.
Okay, what are we minimizing?
We're trying to. We have the so we don't know the supplies, but we have demand, and to make sure they have what we want, the demand, we are trying to keep it low
Mm-hmm. So in other words, which numbers are we looking out for, realistically?
for demands.
So these numbers here, right? 15, 9, 8, 8, 11, and 26?
Mm,
Yes? Yes or no?
mm.
It's min.
Uh, is that why we are minimizing?
Yeah, we're minimizing these numbers here. Alright?
Mm,
So what are we writing
okay.
down?
We're writing 15x11 plus 9x12
Okay?
and 8x13
15x.
and
Okay, you know what? This is not helping. I'm gonna do this manually then.
mm,
15x11 plus
mm,
9x12
mm,
plus 8x what? 8x what?
8 and plus 8x21
Mm-hmm. 8x21
Mm.
plus what?
and plus 11x22
And then
and 26 x 23.
Perfect. Good. Now, what are the constraints?
We have from Jefferson City, from Omaha, and there's to Des Moines, and to Kansas City, and to St. Louis.
Yes. So in other words, the constraints for the audience, just so they know, it's from Sun City, from Omaha, from Des Moines to Kansas City, and to St. Louis. Although some people tell me it's Lois. I don't know if it's true or not. So then, what would this constraint be?
The constraint will be
Hold on. Actually, for the sake of the audience,
x.
so that people know what's going on, because I realized I forgot something a little bit crucial here. This line is x11. This line is x12. This line is x13. This
Yep.
line is x14. This line is x15. And this line here is x16. Just so the my sincerest apologies. That was wrong. It's not 14. It's 2122. Come on, Hanson. If I make a mistake like that, you gotta call me out on it. And 2 3.
So, I didn't realize that was a mistake. I just thought everybody knew that on the homework.
Well, maybe they didn't. Okay, so we gotta help them out.
Okay.
So, how would you write the constraint from Jefferson City?
And then there's x11 plus x12 plus 13. This one is for Jefferson City, yeah.
Yep, and then
And you have less than or equal to whatever Jefferson City is.
it's on the left. 45. All right. Now from Omaha, how'd you do it?
It'll be s21 plus s22 plus s23. And less than or equal to 40.
Correct. Now to Des Moines.
Des Moines is s11 plus s21.
Okay. And what's missing?
And that one will be equal to 20.
Correct. What's next?
X is s12 plus s22. They equal to 15.
Correct. And finally, St. Louis.
S13 plus s23 equal to 50.
Good.
Yeah,
And now,
but I don't know why some of them are less or equal to and some are equal to.
oh, because you want to have as many as possible going in, okay? But going out, it's going to be less now because you don't know if you meet the demand.
As many going in as possible.
Because, look, you can send 8 from Omaha and 15 from Jefferson to Des Moines. But that's 23, which is greater than 20. But we don't want to go above 20 because 20 is the demand. Therefore, it's equal because we're trying to meet the demand. Does that make sense?
Yeah, so it has to be less than 20.
No, not less than, equal to, because you don't want to go less than the demand. Otherwise, you're just not fulfilling the needs of the consumer. And you don't want to just
11 plus 20.
Yeah. So now, what's the last constraint?
So x11, x12, x13, x21, x22, and x23, they're all greater or equal to 0.
Correct. Now, sadly, the rest of the question requires a solver, so we're not going to do it.
Mm,
Good.
mm,
Okay. Let's do the next
mm,
question. What'd you think of this question?
mm.
And having this thing here. Does seeing it drawn out help?
Yeah.
Good.
Mm.
Now, second part.
But there's one thing I don't understand. Hold on.
Okay. What do you not understand?
So earlier you say we want to meet the demand.
Yeah.
So we use the less or equal to sign.
No, when you want to meet it, you want to equal it. 20. You want to equal
20.
15. You want to equal 50.
Mm,
But, as you know,
mm.
45, you don't want to send 45 to a location of 20.
Oh,
So you don't want to send it equal. You want to do less than or equal.
oh, okay.
Does that make sense?
Even, yeah, the one to be equal to, and that one is less than, okay.
Yep. So now,
Wait, so if there are three shift one, then shift two, shift two, then it's a certain number, so it's equal. But shift one, hmm, I don't, I don't understand this one. There's Jefferson City and Omaha. They are shipping like three routes
yes.
out of them. So it's less or equal to y.
Because you can't send. Let's look at Omaha for a second. It had 40, right?
Mm,
Well, the problem is you don't want to send 40 to one route. Therefore, you have to
mm,
send less than. You could send 40, which is why it's also equal to.
mm,
However, for 20, you don't want it to be greater than 20, because if it is greater than
mm.
20, what ends up happening is no one gets satisfied.
Okay.
Good?
Yeah.
Okay, perfect.
Mm. Well, Miguel.
Yeah.
So thank you for teaching me all this. Unfortunately, I gotta go now.
No worries, okay? Alright, gentlemen and
Mm,
ladies, if you are watching this, we're gonna take a short break, maybe like 30 minutes. I'll be back and message everyone else. When we're back, we will still be here. Have a nice day.
mm. Yeah, I'll probably come back at 5. Got an appointment to go to.
Okay, go for it.
All right.
Bye.
Thanks, man.